Hey, everybody. Thanks for joining us today at the Virtual Storage Developer Conference. We're going to be talking about smart fabrics today. We're going to be talking about how Fibre Channel is becoming a self-healing network. My name is Brandon Hoff. I'm Principal Architect from Broadcom. And then Rupin is going to join me for this presentation. Rupin, go ahead.
Thanks, Brandon. Hi, folks. My name is Rupin Mohan. I'm the Director of R&D, Storage Networking in Hewlett-Packard Enterprise. This is a Fibre Channel Industry Association, FCI sponsored presentation, and I'm also the marketing chair for FCIA. So thank you for taking the time for dialing in, and let me take you through the agenda next. What we cover today in today's presentation is a brief introduction to the trends we are seeing in the enterprise and kind of leading to why we are solving the problems we are trying to solve in this, that we'll talk about in this talk around fabric notifications, congestion management, and how to solve the problem of degraded links and optics, using fabric assisted MPIO. So we'll discuss all those in detail. Brandon will take you through those details in his section. So let me take you guys through the IT trends that we are seeing. So what are the IT trends we are seeing within our customer base that's driving the need for autonomous SANs? The first thing we are seeing is a lot of complexity in the data centers of our customers. Data centers have become complex, and they really become a lot more denser than they were. The same sort of infrastructure is supporting more virtual machines, more containers, and that complexity level has really gone up. And what really customers want to do is be more agile with their infrastructure. Things that they can do things correctly, and they can do things really fast. The second important trend we're seeing is around efficiency and performance. Customers have made a lot of investments in their on-prem infrastructure, and they're looking at ways on how can they be more efficient with it, how can they get more performance out of it, how can they get more IT for maybe lesser dollars, right? So what we're doing, with the technologies we're building, inside our standards organization, T11, is, what can we build inside the Fibre Channel protocol to make it easier for customers to get more performance and more efficiency out of their infrastructure. And we'll discuss that also today. Another angle that is becoming more and more important is around automation orchestration, and the need for being able to kind of automate not just day zero activities, but like day one, day two activities around managing your infrastructure. And especially during the COVID environment, when everybody's remote, a lot of people are remote, the need for more automation and more orchestration has become kind of front and center. The third most important trend we're seeing in our data centers within our customers is around resources, right? Budgets are getting tighter. People are hiring more generalists, more athletes, folks who can work on different areas, within their environment, and not necessarily be, siloed in SAN infrastructure. So with that, also, I think the need for more automation, more orchestration, and more autonomous SANs, wherein the protocol can help solve the congestion problems without customers having to have the expertise to look at Fibre Channel traces or do some deep level debugging to find out what's going on in the SAN. So these are the three important trends we're seeing in the industry. Another area we are focusing on is around automation or orchestration, as I mentioned before, and how can we kind of make deploying and managing SAN simple for our customers. And the industry has developed a lot of tools and from different vendors. And since we are this session is sponsored by FCIA, we like to remain vendor neutral in our presentation, so we necessarily don't want to talk about a particular company's product. But as you've listed here in this chart, there are plenty of products out there, including one from my company, which is OneView and SmartSend and Network Orchestrator. Okay. When you try to solve problems and try to automate and orchestrate, SAN, you can do it at multiple levels. You can do it at very high level, using Ansible playbooks. This is, for the most generalists out there. They can use ready-made playbooks to deploy and configure, manage SANs and infrastructure, including the storage arrays. For folks who are more DevOps type folks, people who are good in programming or they like to do programming, whether they're good in Python or they're good in traditional language like C, C++. I think we have the libraries, the Python libraries and the REST API libraries, pretty comprehensive set of libraries out there for our customers and for our IT, generalists, for data center managers to kind of develop their own scripts, develop their own tools to customize to their particular environment. We have these capabilities today with the Fibre channel. The last thing that we have been doing over the past few years, and we continue to do today, is kind of built in technologies inside the protocol, technologies that can really help make customers' life very simple. Example is all the work we did around pair zoning and target-driven pair zoning, right? So what we heard from our customers is that for new people coming into SANs, zoning is quite a big stumbling block, and it can get a little complicated for newbies. For folks who have been doing SANs and external storage for a long time, for them, FC zoning comes naturally, and they can manage the complexity around it. But for new people, we develop these products, and technologies right around peer zoning and target-driven peer zoning, where basically zoning completely becomes transparent, right, to an end user. And while they're presenting their LUNs and while they're presenting their storage arrays, storage LUNs to the server through present in their arrays, the zoning gets done automatically. The focus of today's presentation is going to be around Fabric notifications and Fabric-assisted MPIO, where you'll find that what we are building in the protocol is the protocol itself helps customers detect congestion in the Fabric and can deliver notifications to the members in the Fabric to kind of alleviate the congestion. And what you will find and what we have learned over the years is when we solve the problems at the protocol layer, it is the most efficient way to solve the problem, and it has the most favorable outcome. So, some of the problems you can solve, at different layers of the stack, but when you solve the problem at the foundation layer, the outcomes are pretty elegant. So with that, I'd like to hand over the presentation to Brandon, who will take you into the detail around Fabric notifications and Fabric-assisted MPIO. Thanks, folks.
Thanks, Rupin. So yeah, first I'm going to start with the definition. Now, this is a developers conference. So Fabric notifications is a new technology in Fibre channel that is open for people to start developing to and coming up with new ideas. We're going to talk about two solutions today, congestion and some link integrity solutions. But there's a lot more that can be done. So what are Fabric notifications? And so FPN stands for Fabric Performance Impact Notification. And there's right now, 4 flavors, if you would. There's a congestion notification, and we call that FPN-CN. And this notifies a port on the Fabric that is causing congestion. And I'm going to explain what that means, and we're going to demonstrate a solution built on that FPN capability. And then we have link integrity, FPN-LI. And this notifies a server port that the link is connected to is sick but not dead. Now we're going to talk about a possible solution in the market. There has been some upstream Linux work being done on that. But of course, more people contribute, the better in Linux world. So open that up. And then there's peer notification, FPN-PN, and then which really is when a FPN-CN is sent, a congestion notification sent to a server that's causing congestion. The peer notification notifies everything else in the zone that congestion is happening on that zone. So that's another one. And then a delivery notification. Basically, fpin-dn, the best example is if a switch drops a frame due to egress hold time. And that's another signal that's out there for us to take advantage of. Signals are actually at a low level. It's part of the Gen 7 standard for Fibre channel. And basically, this is built into the hardware level of Gen 7 ASICs. And this provides, the F-pins I talked about above are really what's called an ELS, which is a standard frame and Fibre channel, but you need to have a credit to be able to transfer that back and forth between the server and the fabric, or the storage in the fabric. Signals are a low level, and they happen a little faster. And basically, for congestion signals, it looks like really rapid fpin-cn. So it's the same information, just sent a different way. The details of these specs, there's a lot of details here, are really in different Fibre channel standards that are listed below, that you can refer to for more details. But we're going to talk about today really a solution in congestion notification, and then we're talking about work done in the Linux environment, link integrity, and the rest of these are things that are open for development, and of course open for development. F-pins can be sent from a server to the fabric or from the fabric to the server. And today we'll talk about just one flavor of that. Built a solution around congestion management to show the benefits that we can making the SAN autonomous. And we'll talk about this in a minute. Basically, what's the problem we're trying to solve? And I'll talk more about this in a second, but basically over time, or if I have a fast array, a workload will grow until it's too big for the hardware footprint. The server asks for too much data, or the storage array sends way too much data to the server, and the server can't consume it off the fabric. Either it's out of CPU cycles, out of memory, out of PCI bandwidth, out of HBA bandwidth. Then what happens in my diagram, congestion is where my little explanation point is. It fills up the buffers of that device. Then what's going to happen is I got no buffer credits. That back pressure is going to trickle through the fabric, and it's going to go to the storage system, and it's going to throttle the storage system. This is how a credit-based lossless network works. The problem here is this becomes the bully server, and it's consumed all the hardware in the fabric, all the buffer resources, and other servers. If you add another server to the network, its performance becomes damaged. Slow. It has a performance impact, and I'll actually show you some real data from that as well. The solution here is a new alert. And so basically, the switch knew that it was being congestion. And the best place to detect congestion is in the fabric. The best place to fix it is in the endpoint. And so here, the switch detects congestion. It sends this new fpin-cn to the server. We're going to talk about that today. And also sends a peer notification that gets sent to the target, or to the storage system. Then the congestion is handled and managed by the endpoint. And the whole idea of putting this together is to optimize the hardware utilization in the fabric. So that's the new solution that we'll be talking about for congestion management. How does this work? Our server teams build new network or install new servers, and they spend a lot of time right-sizing the hardware for the workload. So maybe you're running at 50% utilization, everything's purring along. You don't have any frame drops, you don't have any congestion. You have plenty of hardware resources to service all the IO requests that are coming across the SAN. This is day one. At some point in the near future or the far future, you're going to have somebody, you're going to have somebody move a virtual machine onto a server, or too many virtual machines on the server, or the workload's going to grow. And just remind you, this is just, I'm running out of hardware resources. It's very simple. The hardware footprint is not big enough to serve the application. And this will happen over time. And especially you'll see it pop up a lot more as people add 32 gig storage to their networks. All servers can move into the state. So a lot of end users that I talk to want to start looking at this and using it as a tool to start planning for, okay, I know this is going to happen over time, and I'd like to be able to address it. So this is a good, automated way to happen to solve that problem. So the impact is, I talked about a minute ago about, how, overutilized server talks to the storage system, asks for too much data. Basically, his eyes are bigger than his stomach. The storage system sends that data back across the SAN, but what happens is it consumes the hardware resources of the SAN. This now spreads the performance impact across multiple servers. Basically, outstanding IOs from the bigger, we call that the bully server, propagates across the SAN, and the other servers, and I actually put little dials here. You'll see the victim servers, they'll drop in performance by factor 2. So even though you look at this, you look at your bully server, it's running 100%. It looks like everything's going good. Back pressure's working, not dropping in frames. You might have some retries, but now you have a bunch of trouble tickets being issued by different server administrators or different application administrators because their system just cut down, just basically the performance cut in half. This congestion, I said, can impacts other workloads. And here's the performance of what that looks like. So basically the top row, I had a workload that I was running. The bottom one is the victim server. It was running great. It's running nearly line rate in bandwidth. And you can see right when I turn on the bully server goes to full bandwidth and the victim server cuts in half. As I said, users start filing trouble tickets to the administrator. Everybody says, starts pointing fingers. Where's the performance problem? And now we have a way to take a look at this and mitigate it. So the new solution is Fabric Notification. It points to right where the problem is, and so we can solve this. We can solve the problem autonomously. So in this case, F-port congestion is detected in the fabric, and we send this new signal called an FPIN. As I said, this is called the Fabric Performance Impact Notification, and -CN means congestion notification. And this is sent to the server that's causing the challenge, that's filling up the fabric. Now you can decide what to do with this. It might be that this is a new technology. When you have a new technology, you always need to really have great visibility into it and see the before and after and make sure that it's doing what you think it should be doing. So the first thing you're going to start charting that, and then you can turn on congestion management if you like. So that's where you need your tools in there. So you need to go through your different SAN tools, your storage tools, your server tools to start taking a look at the congestion in there and deciding from a company. So you might have a tier 1 workload. You're like, I don't want to touch that. I'm just going to let it go. I don't mind if it's backing up the SAN because it's so important. Everybody else can suffer. Tier 3 workloads on this, you say, I might just turn on congestion management because I'm not worried about them. I can go and take a look later, and if something's not working right, I can make adjustments, but I'm just going to make sure that they don't cause problems with my SAN. So once you decide that, you can turn on congestion management, and this is kind of what it looks like. So once I saw the fabric notifications, the FPIN SANs, we send this new signal, and this is we're showing the signal in the bottom. So the top one's the bully flow. I turn them on. The second one is the fabric notifications, and it says, hey, I don't have any fabric notifications. No, and then all of a sudden I have full fabric notifications at the same time the bully server turned on. So as I said before, the bully's eyes are bigger than its stomach. Best place to detect congestion is the fabric. Best place to mitigate congestion is the endpoint. And now we're saying this new solution, this new signal, and now we can mitigate. You turn on congestion management, and I'll show the graphs here in a second. But basically, I throttle back the bully server. And a lot of people would use QDEPs and stuff like that as the way to do that. But it turns out that wasn't the best tool for the job. And so there's a better way to do congestion management. And there's actually opportunities to innovate for congestion management as well. But I've returned the performance of all the other servers to where they're operating before. And I've optimized the performance of the SAN to really utilize the hardware resources that it has to the best of its ability. So I don't have one server consuming everything and nothing getting distributed to the other servers in terms of hardware resources. Now note the bully workflow, if it's transient, it just might be busy at night or during some kind of special batch job. This can handle transient things because it can be adaptive. On the other side of it, it might be something that the administrator needs to go take a look at, such as I've got way too many VMs on this hardware and I just need to migrate a few of the VMs off. or if I have a workload or a database workload, I need to split that workload between more than one server. So it doesn't mean that we've magically created hardware resources out there that weren't there before, but we definitely make sure the solution works in the most optimal capability as we can. Benefit is, you can see, this is the top one is the bully server, the bottom is the victim server. And, I've slowed down. If I look at, state 1, state 2, state 3, state 1 is when I was congested. State 2 or point 2 is where I turn on congestion notification. And then state 3 is a steady state. So you can see in the bottom, I've returned performance nearly to where it was before, and then it bounces back and forth as this is an adaptive algorithm we're running. But basically, we restore performance on the bully server, so you're not getting help desk calls or trouble tickets being issued and stuff like that. And you can see the bully server, we slowed down a little bit. And in this case, we slowed it down about 30% where the system balanced out. There's a bonus here too, is you'd think, well, I slowed this down, it's not running as well as it should be. It turns out that I dropped the latency on the bully server considerably, by 2 orders of magnitude as well. So you created a better operating point for the entire storage network. So that's it for congestion management. I'll talk about availability in a second. Congestion management is something available that's in the market today. The nice thing, so here I'm going to talk about a second one. So this is an FPN-LI, which stands for Fibre Performance Impact Notification Link Integrity. So this just sends a link integrity. So if I have a sick but not dead optics, like my CRC error is too high, there's different types of counters I can use, but you set that up and you send a signal to the other side saying, hey, this is not a good path, don't use it anymore. So how's this work? And as I said, this is one that's not available yet. It's one that can use more innovation, can be great to have some other developers, other companies help us out with this. And in terms of Fibre Channel or other companies. But here's how this one is, theoretically, we're planning on this working. Under normal operations, Fibre Channel links, I have SAN A, SAN B, and I have dual paths, and I have multipath running, right, MPIO, so that I'm load balancing, also has capability of failover. Now, if path 1 goes out, goes dark, it's obvious that I got a problem. I just switch over to the second path, and everything's great. But over time, we know that the optics, once you put them in a system, they start degrading at day 1. And it's the point, when we talk to customers, the point of pain is the 2 months before an optics fails, or somebody kicks a link or an optical cable and creates, breaks it or pinches it, is really before it fully fails. And that's when I start getting a lot of errors sent across the SAN, and it starts causing, a lot of, back pressure and errors across the entire network, causing a general performance problem. And that's really the whole sick but not dead issue. I'm going to see that that link degrade in performance, and then IOs in the server can get backed up, pushing, and so I get back pressure in the server because I might be load balancing, round robin. And then once I have a bunch of slow IOs off one link, fast IOs off the other link, it's going to start really slowing down that workload overall. So quick detection and action is essential. So this is the new signal, as I said. We have this FPN-LI, and this is sent to the HBA. And this is when the fabric says, hey, I've got a link integrity, and something, usually user program, some threshold is met, the signal sent to the server. Now we can do something with that signal. So that FPN-LI goes to the server, it gets passed up the stack. The idea is that this goes to the multipathing software. And so at this point, you can see this takes a lot of different partners in the ecosystem to make this one work. But that pin gets sent to the server. It gets passed up from the HBA drivers. So the HBAs are just passing information up into the SCSI stack and then to the MPIO stack. And this is, if you look at Linux, we've been doing work in Device Mapper, we've been doing work in SCSI stack to be able to make this happen so the signal can get moved up. Yeah, so this is, as I said, a project in process. And basically, it's an opportunity to do some, contribute. And we're going to need help from all the operating systems, the kernel guys, as well as the different hardware vendors for this one to become in the market. So these are two different solutions that we talked about.
Quickly.
Yeah, go for it.
Yeah, so this is what I was talking about, right? I mean, here's another example where the problems can be solved at different layers of the stack. Some may argue that this problem, has been partially solved. If you just have to use the right, MPIO, load balancing algorithm, right? If you use, response time as a basis, you could maybe detect, the response times going up in that sick link, and direct IOs to the healthier link or with better response times. But like I said before, if you solve the problems at the protocol layer, at the foundational layer, if you solve the problem at that layer, you get a better outcome in terms of a solution. So this is an attempt to really solve the problems at the protocol layer. Go ahead, Brandon. Thanks.
Yeah, no, actually, I was gonna, this is the link integrity solution. I'm gonna bounce back to the summary of the notifications. So as they talked about, here's the list of Fabric notifications. There's actually 8 different solutions in this list. You have a congestion notification. This can be sent from the HVA to the Fabric or the Fabric to HVA. I just showed a solution built on the Fabric to the HVA. There's other opportunities to build solutions if the HVA sends the Fabric the same signal based on congestion, it might be same. So there's definitely opportunity there. There's opportunity in link integrity today. Peer notification, there's no announced solution there, but one idea that we've had is that a storage system, that when I get a congestion notification sent to the server, the storage system will also get the peer notification, so congestion is happening somewhere. And so if I have like a 32 gig array, I could have an 8 gig server out there somewhere. The array can then rate limit the data it sends back to the 8 gig HBA, and it creates a nice solution there as well. And the delivery notification, we're looking at ways to take advantage of that as well, and looking for use cases there. So, of course, the engineers who developed this had some great ideas. The first one that we've launched is around congestion notification, but we're looking for, there's definitely some developer opportunities for the rest of this. OS vendor support. So for congestion management, and I should put that on the screen, Fabric notifications developed by T11, so it's an open standard by anybody who participates or has access to the T11 documents. The switch support was announced from Broadcom, so we do definitely have switch support, and of course we know that Cisco is going to support these things as well. And then HVA support, we do have Broadcom support as well as I know there's a great blog out there by the Marvell team about their support as well. So contact your vendor for more details on exact what support means and what versions of OSs and firmware and drivers are available for this today. And a lot of the things from an HBA point of view, of course, I'm in the MLX division of Broadcom, is that we are surfacing this information so that other people can write software to take advantage of this. So yeah, these are available solutions today.
And everything standards based, right? The key point here is, we're part of FCI T11, and all the solutions we're developing, that Brandon's talked about, they're all based on standards and available to everybody to contribute.
Yep, that is correct. And that's really important here because the ecosystem is important to make sure that we support everybody. Turns out, but we do have some good data from, that we could show how this makes a difference in data centers today and builds an autonomous SAN and an autonomous fiber channel, which makes this an interesting solution. So overall, Fabric Notifications is a new platform to for delivery of better networking solutions. Adaptive solutions are available today, and then get involved, kind of what we've been talking about. So at this point, I think the virtual platform will allow us to take questions. So Rupin, any other comments you have?
No, thanks, Brandon, for taking the audience through the details. I think, Brandon, you and I will be available to answer questions on the online platform, but I think we should end the recording on a good note. Thanks.
Thank you.
All right. Thanks, guys.